Okay, so now we want to talk about what determines how a rock is going to deform. So there's basically three different things that a rock is going to do whenever you apply a stress to it. Okay, so at first it's either going to stretch or be compressed like a spring. Okay, so it's behaving elastically. So what that means is that after you apply the stress to it, that rock is going to return to its original shape. Okay, then you could apply a stress to a rock and it would behave plastically. So that would mean that it's going to bend, and then when you stop applying the stress to it, it's going to remain in whatever shape it was left in. And then the third thing it could do is it could break. So if you apply too much stress to a rock, it's going to break, it's going to rupture, and then you're going to have a fault. All right, so what are the things that are going to determine whether or not it's going to do one of those three things? Okay, one is the amount of stress that you apply to the rock. Okay, so let's say that you've got a rock and you apply a stress to it, but not too much stress. Well, you might be able to squeeze the rock, and then when you stop applying the stress, it just pops back out into its original shape. But if you apply too much stress, then it's either going to bend plastically and not return to its original shape, or it's going to rupture. Okay, the next thing is going to be confining pressure. So confining pressure is the pressure that something feels because it's under the ground. So the deeper it is under the ground, the more confining pressure is being applied to that rock. And so once again, that can determine what it's going to do when you apply the stress to it. Okay, the type of rock. So is the rock made of limestone, or is the rock made of granite? So some kinds of rock are going to be a lot tougher than others. So that if you apply a stress to limestone, it's going to compress pretty easily. But if you apply the same stress to granite, it's not, because granite is a more sturdy rock. It also depends on the amount of fluids inside the rock. So they can also determine whether something is going to break or something is going to bend. So like for example, rocks that are being subducted into the earth have a lot of water in them. And so that means that they're going to be more likely to be able to melt, which means they're going to be more likely to be able to bend than if they're dry rocks. Okay, it's also going to depend on the temperature. So that under cooler temperatures, rocks are going to tend to break. But under higher temperatures, they're going to tend to bend and they're going to deform. And then it's also going to depend on the amount of time. So like for example, if you have a rock, or let's say that you got a stick of wood, and you very quickly apply a stress to it, you're going to break it. But on the other hand, if you apply that stress very, very gradually over a long period of time, you could then let go of that stick and it would stay bent. So it's also going to depend on the amount of time that the rocks are going to be subjected to these various kinds of conditions. Now, does this sound familiar? So in a previous lesson, did we talk about something else that would depend on the amount of stress and the pressure and the type of rock and the fluids and the temperature and the time? Yes, we did. It was called metamorphism. So metamorphism is going to be intimately related to what these different kinds of rocks are going to do. Okay, let's take a break, and when we come back, we're going to talk about parallel structures and what they look like from the side view, and then what do they look like from the top-down view.